There are discoveries that expand our understanding of the universe, and then there are discoveries that break it. Not challenge it. Not refine it. Break it. And right now, something observed by the James Webb Space Telescope is doing exactly that. This isn't just another deep space image. This isn't another distant galaxy added to a catalog. This is something far more unsettling. Because what Webb is seeing should not exist. Imagine looking back in time, billions of years, into a universe that has barely begun. A universe that should be dark, chaotic, unfinished. A place where the first stars are only just beginning to ignite. That's what scientists expected. But that's not what they found. Instead, Webb is revealing something completely different. A universe that looks already grown up. When the NASA deployed the James Webb Telescope, its mission was simple in theory: look deeper than ever before. Capture the earliest light in cosmic history. Witness the birth of galaxies. And it did look deeper, far deeper than anything humanity has ever built. But what it discovered wasn't cosmic infancy. It was cosmic maturity. In one of Webb's earliest deep field observations, astronomers noticed something small. Almost insignificant. A faint object. Barely visible among thousands of distant points of light. At first glance, it didn't seem important. But then they measured its brightness. And everything changed. It was too bright. Not slightly unusual. Not within acceptable margins of error. Impossible levels of brightness. The kind that simply doesn't fit into any known model of early galaxy formation. Naturally, scientists assumed a mistake. Maybe it was closer than it appeared. Maybe the data was skewed. Maybe something interfered with the reading. But then came spectroscopy, the ultimate truth check. And the results were undeniable. This object wasn't close. It was incredibly far away. So far, in fact, that its light began its journey when the universe was only a few 100 million years old. And that's where the real problem begins. Because what they were looking at didn't resemble a young galaxy at all. It looked evolved. Structured. Massive. Like something that had already lived through billions of years of development. That's not just unexpected. That's impossible. And then came the second shock. It wasn't alone. As Webb continued scanning deeper into space, more objects appeared. Dozens of them. Each one carrying the same disturbing signature: too bright. Too massive. Too organized. Too early. This wasn't a one-time anomaly. It was a pattern. And patterns are dangerous, because they can't be ignored. For decades, cosmology has relied on a framework known as the lambda-CDM model. It's the foundation of everything we think we know about the universe: how galaxies form, how matter evolves, how structure emerges over time. According to this model, early galaxies should be small, dim, irregular. They should grow slowly over hundreds of millions, if not billions, of years. But Webb is showing something else entirely. Galaxies that seem to skip the entire process. Galaxies that appear finished. Imagine opening a book at page 1 and finding fully developed characters already at the end of their story. That's what this feels like. And the deeper scientists look, the worse it gets. In some of these early objects, researchers are observing star formation rates that defy physical limits. In today's universe, galaxies convert only a fraction of their gas into stars. There are limits, rules governed by cooling, gravity, and feedback from stellar explosions. But Webb is revealing objects that appear to ignore those rules completely. Some of them seem to have converted nearly all their gas into stars. Not gradually. Not over time. But rapidly. Efficiently. Almost instantly. And that creates a terrifying possibility. These might not be galaxies at all. They could represent something entirely unknown. A category of cosmic structure we've never seen before. Something that doesn't fit into any existing theory. And if that's true, then we're not just missing details. We're missing entire chapters of cosmic history. But perhaps the most unsettling mystery isn't what these objects are, but here's where things become even more unsettling. Because the problem isn't just what the James Webb Space Telescope is seeing, it's how many times it's seeing it. At first, scientists hoped the early anomalies were rare. Outliers. Statistical noise. Cosmic coincidences. Because science can handle one anomaly. It can even handle two. But it cannot easily survive dozens. And Webb didn't find just one impossible object. It found many. Entire regions of deep space, areas that should represent the quiet, early stages of the universe, are filled with these strangely mature structures. Galaxies that shouldn't exist yet. Galaxies that seem to have formed too fast, grown too large, and evolved too quickly. This creates a cascading problem. Because if even a handful of these objects are confirmed, the consequences are enormous. But if most of them are real, then the foundations of modern cosmology begin to fracture. The standard model of the universe, often referred to as lambda CDM, relies on a very specific timeline. First, the universe begins in a hot, dense state. Then, it cools. Matter forms. Gravity slowly pulls that matter together. Small structures form first. Then larger ones. Everything builds gradually. Step by step. But Webb is showing us something completely different. It's showing a universe that doesn't build. It appears. Fully formed structures emerging where only the earliest seeds should exist. It's as if the universe skipped its own childhood. And this leads to a deeply uncomfortable question. What if our timeline is wrong? Not slightly inaccurate. Not in need of adjustment. But fundamentally broken. Because time itself plays a crucial role in everything we understand about cosmic evolution. Without enough time, galaxies cannot grow. Stars cannot form in large numbers. Heavy elements cannot exist. Structure cannot stabilize. And yet, Webb is showing all of those things happening far too early. Some of these galaxies appear to contain enormous numbers of stars, comparable to galaxies that should have taken billions of years to evolve. But according to their distance, they shouldn't have had the time. That's not a small inconsistency. That's a direct violation of the timeline. And when the timeline fails, physics starts to lose its grip. Now here's where things take another turn. Because astronomers aren't just looking at brightness and mass, they're analyzing light itself. Through spectroscopy, scientists can break light into its components, revealing the chemical fingerprints of distant objects. And what they're finding is just as shocking. Some of these early galaxies appear chemically evolved. They contain elements that should not exist yet. Elements that require multiple generations of stars to form. That process takes time. A lot of time. Stars are born, they live, they explode, and only then do they enrich the surrounding space with heavier elements. This cycle repeats again and again. But Webb is seeing signs of that process, already completed. Which means one of two things must be true. Either these galaxies somehow evolved at impossible speeds, or they didn't start from scratch at all. And that second possibility is where things become truly unsettling. Because it suggests that structure may have existed before the era we consider the beginning. For nearly a century, the Big Bang model has served as the cornerstone of cosmology. It describes a universe that expands from an initial state, growing, cooling, evolving over time. It explains the cosmic microwave background. It explains the distribution of galaxies. It explains the large-scale structure of the universe. But it depends on one critical assumption: that the universe began in a relatively simple state. A blank canvas. But Webb is painting a very different picture. A universe that doesn't look simple at its earliest observable moments. A universe that looks prearranged. And if that's true, then the Big Bang might not represent the true beginning. It might represent something else entirely. A transition. A boundary between phases. Or even just the limit of what we can observe. Because there's something important we often forget. When we look deep into space,